Okay guys, today we're going to take a look at binomial expansion. So this is, you might be wondering why this is in this section. It is kind of a shortcut, of course, to foiling. And you're going to see some patterns in it. I know we've been working on sequences and series. There's some patterns to this binomial expansion. So when we talk about binomial expansion, two terms, and of course we're going to have something a little more exciting than squared just coming at you. I'm going to show you how you can get the coefficients so we can avoid foiling. I'm going to show you a shortcut to get those coefficients. That is this Pascal's triangle. So these are some simple problems to take a look at, what we're used to doing. X minus 3 squared, of course, we would write that out twice and do our full foiling. So I'm going to have x squared minus 6x minus 3x minus 3x. Let's combine it. And then, of course, plus 9. I mean, that's pretty easy to expand. We can do that simple. X plus 2 cubed. We would have to write this down 3 times. Now, I'm going to distribute these first two together. So I'm going to have x squared, 2x, 2x. Let's combine it. 2 and 2. Got it. Now, from here, of course, I'm going to distribute from the back just to make my life a little easier. Write small, x squared and x and 4x. X and 4, and now let's distribute the 2 through. 2 and x squared, 2 and 4x, 2 and 4. And obviously combine our like terms here and get our final answer. Let's add our x squareds here together. And our x's, we're going to have 12 and 8. Time consuming. Now imagine if this exponent on your expansion was like 6 and you had to write it 6 times in FOIL. That would take forever. So we're going to show you some shortcuts today. So why this is in this section or this chapter? Patterns. Take a look. Let's make some observations. So I'm zeroed in on these exponents of our expansion. First thing let's talk about is how do those exponents relate to the number of terms in your answer. I'm going to start at the bottom row. So our expansion exponent is 5. There's 1, 2, 3, 4, 5, 6 terms. Above it, fourth, there's 1, 2, 3, 4, 5 terms. So there's always one more term than your exponent. So one term more than the exponent. Okay, some other observations. Let's look at our terms here. A, for instance, starts at the exponent, 3, and it's going down 2, 1, 0 a's here. No need to write that. So the exponents of a are, of course, decreasing by 1. Let's look at b. So here are b. We have 0 b's, 1 b, 2 b's, 3 b's, 4, 5. So the exponents of b, they increase by 1. And that pattern holds true every time. Now, the sum of the exponents of each term. So for instance, here we have 1 and 1, 2, 2, 2. They should always total the expansion exponent. Need a bigger blank. So those patterns are always going to be true. Because I'm going to be able to do these expansions with only 2 lines of work. I will not have to do a lot of crazy foiling and have a half sheet of paper. Now the other thing we have to calculate for these terms are the coefficients. These numbers in front of each term. The C represents those coefficients. I'm going to show you how you can punch those in your calculator. Now again, just to make sure we have this all crystal clear, remember the first term of the binomial starts at the exponent and goes down by 1. The second term of the exponent starts at 0 and it goes up by 1. So always kind of think high-low. The first term starts high, second term starts low. Now you might see this expression today too. This is the same thing as the combinations, which of course are in your calculator, and that's the first thing I'm going to show you how to punch in. So pull up your calculators here, and it's going to be in your math menu, over in probability, and you can see it's number 3. So if I want to type in example 1, I have to put the 8 in first, the subscript, math menu, probability, and then number 3. Let's put in the 6. Got it. So 28. Let's do B. Now remember, this is the same problem, just a different notation. Means the same thing. Let's punch that guy in. So 10. Math menu, probability, number 3, and 6. We got it. So 210 for that guy. So let's take a look at this pattern at the top here. Because this is our next problem, we're going to do the full-on expansion. We've talked about the first term exponents starting at the expansion and going down, and our second terms, of course, start at 0 and go up. To get the coefficients, we're going to have to punch all of those into our calculator. So here we go. So my coefficient is, of course, 4. So the first thing we're going to type in is the combination 4, 0. That will give you the coefficient. Now, the first term of our binomial is x. That's going to start at 4. Y will start at 0. Now, is it necessary to write y to the 0? No, but I'm going to put it just for the pattern. My next coefficient, 4, 1. I'm going to have to type that into the calculator. X is going to move down in power. The y moves up. Next coefficient, 4, 2. X, of course, is going to move down in power. Y moves up. Next coefficient, 4, 3. X moves down in power. Y moves up. And our last coefficient, 4, 4. X is down to 0. Y cubed. Okay, so here's where we're going to pull out our calculators. We're going to start punching these in for math, menu, probability, number 3, and a 0 for the first one, and I get 1. Okay, that was fun. So 1. Now remember, I said we can do these in 2 lines of work. So my first answer, my first term of my answer, I've got 1 times x to the 4th, y to the 0 is 1. I'm just going to put it as x to the 4th. Now I'm going to get my calculator out again. I'm going to type in 4, math menu, probability, number 3, and a 1. Okay, so we got 6 for that, or I'm sorry, we got 4 for that. So that's my next coefficient, x cubed, y. And then I typed in 4, 2. You don't need to see me keep typing them in. Then I did 4, 3. Okay, for that guy, of course, I got 4. xy cubed. And then I got another 1 for this one. This is going to be 1. So my last term is going to be, this should be a 4, guys. Sorry. All right. Now, I find it a little tedious to type in all of those combinations. So the next thing I have is Pascal's triangle. This is a shortcut to figure out all of those combinations so you don't have to type them in. So first, let me show you how to make it. It's always going to start with a 1 at the top. I'm going to move 1 slot to the left. That row starts with a 1, end with a 1. You always start each row with a 1. So I'm going to move a slot to the left. Now this time we're going to have a middle number, 1 plus 1. I add up those previous numbers from the previous row. Kind of like a recursively defined sequence where we use a previous term to make the next one. Threw that in for fun. Okay, start with a 1, 1 plus 2, 2 plus 1, and then end with a 1. I could do this all day. Start with a 1, add the previous numbers, 1 plus 3, 3 plus 3, 3 plus 1, end with a 1. Start with a 1, add your previous row, 1 plus 4, 4 plus 6, 6 plus 4, 4 plus 1, end with a 1. So what is all of this? So of course, anytime our power is 0, anything to the 0 power is 1. If our power is on our expansion is the first, you would have, of course, 2 terms, 1 additional term. The coefficients would be 1 and 1. 1, 2, 1 would be for our second power on the expansion. Third, fourth, and fifth. Now, this takes the place of, for instance, this would be, of course, my 5th power. This would be 5, 0, 5, 1, 5, 2, so on and so forth. It saves you having to type all of those in. Now, if you flip ahead, I can see there's 1 to the 6th power. Let's put one more row on here. So I'm going to add the previous 1 plus 5, 5 plus 10, 10 plus 10, 10 plus 5, 5 plus 1, end with a 1. So I don't care how you get the coefficients, whether you do it off the triangle or, of course, you want to punch in your calculator all those combinations, as long as you can get them. You will not be provided a triangle, you're going to have to make it. And if you look at your notes towards the end after this section, I did put a triangle in there you can use, of course, on your homework. But here we go. I don't want to type in all the combinations, so I'm going to back up to my triangle here. Of course, my 5th power row, 1, 5, I'm going to jot these down, 1, 5, 10, 10, 5, 1. Start with that. So of course there's 6 of those green numbers because we're going to have 6 terms in our answer. So first term 1, coefficient. First term in my expansion is 2x. That's going to start at the 5th power. 3 would start at 0. Now you don't need to write 3 to the 0, but I'm going to put it on for the pattern. Then of course 5. 2x is going to move down to the 4th. 3 moves up to the 1st. Next coefficient 10. 2x moves down to the 3rd. 3 is going to move up to the 2nd. Next coefficient 10. 2x moves down in power to 2. 3 moves up in power to cubed. And my last term to get it will be 1. 2x, of course, my second to last coefficient here is going to be 5. 2x is going to be to the 1st. 3 will be at the 4th. And my last term, 2x to the 0. We're going to sneak it in. 3 will be to the 5th. Now remember, I said instead of writing this out 5 times and foiling, I can do these in 2 lines of work. So I'm just going to finish calculating these. Now, 2 to the 5th, you're going to, hopefully, maybe you know it, punch that in your calculator. It's 32. I'm going to have x to the 5th. 3 to the 0 is 1. 1. So times 1, we don't need to put the 1. Then for the second term, I did 5. 2 to the 4th, I just know it, and 3 to the 1st, and of course 3. So I punched in 5 times 16 times 3, and I got 240. And of course, x to the 4th. Third term, 10, I punched in my calculator, 2 cubed, 3 squared. So I just did 10 times 8 times 9, 720. And we're going to have x cubed. Next term, I did 10, 2 squared, 3 cubed we know is 27. So I did 10 times 4 times 27. You get kind of a big number, 1080. We're going to have x squared, 2 terms to go. I did 5 times 2 to the 1st, 3 to the 4th. Maybe you know that 81. You could just do 10 times 81 there, 810. And then my last term, 1, I'm not writing that. 1, I'm not writing it. 3 to the 5th. Got it. So final answer if you wrote that out 5 times and did all of the lovely foiling. Let's do a couple more. Okay, so for our next one, of course, we can see we're to the 5th power again. So the first thing I'm going to do is just jot down those coefficients that I got right off my Pascal's triangle. And again, don't forget, you could do in your calculator combination 5, 0. That will give you the 1, 5, 1, 5, 2, so on and so forth. So let's set it up. First coefficient is a 1. Of course, the first term in our binomial, I'm going to put times there so it doesn't look like an 11. That's going to be to the 5th power. Let's make sure we take the sign, negative 4x, start at 0. And again, you don't have to write that since it is 0, but I'm going to put it for the pattern. Now, next coefficient, 5. Our 1 is down to the 4th, negative 4x up to the 1st. Okay, next coefficient in our line, 10. 1 is down to the 3rd. It's nice that it's 1. Obviously, 1 to any power is 1. So that's going to be easy and quick to calculate for us. Next coefficient, 10. Our blue 1 is down to the 2nd. Negative 4x is cubed. 5. 1 is down to the 1st. Negative 4x is going to be at the 4th. I'm going to try to sneak this last term in. Our blue 1 is going to be down to the 0. Again, not necessary to write that, especially being 1. And of course, our negative 4x is going to be at the 5th. I think I'm going to make it. So remember, in general, that's a 5, a power of 5 there. You can do these in 2 lines of work. So my first term, 1, 1, anything to 0 power, 1. Got it. Now, because we have a difference, our expansion sign is subtraction, our signs here between the terms should alternate, which they will, because I'm going to have 5, 1 to the 4th, times negative 4, so negative 20, x to the 1st. I'm just going to put x. We're going to have 10, 1, negative 4 squared. Make sure you square the negative. 16, so 10 times 16. 10, 1, negative 4 cubed. So I'm going to do 10 times negative 64. And let's remember our variable. 5, 1, and then negative 4 to the 4th. So of course 4 negatives will make a positive. So 5 times 4 to the 4th, we're going to get 1,280. Yes, I typed that in my calculator. And then at the very last term, 1, 1, and then I just did negative 4 to the 5th in my calculator, negative 1,024. Got it. So on your subtraction, on the difference, remember the signs should always be alternating. That pattern's always true. Okay, let's take a look at this guy. Ooh, to the 6. I gotta back up and look at my triangle, my 6th power coefficients right here. Now, if you're doing these with combinations, you have to type in 7 different combinations. I don't have that in me, kids. So I'm gonna use my triangle. 1, 6, 15, 20, 15, 6, 1. I don't know if I'm going to fit this all in one row. I'm going to try to write small. We'll see what happens here. First term, 3r. That's going to be at our 6th power. 2s then will be at 0. Again, you wouldn't have to write that. I'm just going to put that for our pattern. Next term coefficient is 6. 3r is going to be down to the 5th. And 2s will be at the 1st. Okay, 2 out of 7. Keep going. Next coefficient, 15. 3r will be down in power to the 4th, and 2s increases in power to a squared. Next coefficient, 20. 3r decreases in exponent to a cubed, and 2s to a cubed. Okay, 3 to go. 15. 3r down in power to squared, and 2s increases to a 4th. Okay, I knew I was going to make it in one line. 2 to go. I'm going to sneak them down here. So I'm on 6. So 3r now down to the 1st. I was close, kind of. 2s increases to the 5th. And remember, your powers in each term should total the expansion exponent of 6. So 1 and 5, 6. We're doing good. 1. 3r would be at the 0. So again, not necessary to write that because anything to the 0 is 1, but I'm going to put it for our pattern. 2s, 6. All right, let's get our answer here. Lots of calculations. So you're going to get some big numbers here, obviously. Now at the beginning, 1 times, I'm not going to worry about the 1 times. In my calculator, 3 to the 6, I did type that in. It's 729. I'm going to have r to the 6. And then 2s to the 0, of course, is 1. Next term. So I had to do a lot of this in the calculator because 3 to the 5th is a large value, 2 to the 1st. So I typed all of that in. You get 2,916. And then don't forget your variables, R5, S1. R to the 5th, S to the 1st. I'm just going to put S for that. Third term, I did 15 times 3 to the 4th. 2 squared, I just put times 4 for that guy. And of course, I multiplied that out. Another large answer, 4,860. R to the 4th, S to the 2nd. Okay, 20. 3 cubed, I got that. 27, 2 cubed, 8. So I did 20 times 27 times 8, which gave me 4,320. Don't forget your variables, R cubed, S cubed. All right, 3 to go. 15, 3 squared. 2 to the 4th, I actually got that one. So I did 15 times 9 times 16 in my calculator, 2,160. R squared, S to the 4th. Really, I'm running out of room. Okay, so here we go. 6 times 3 to the 1st, 2 to the 5th. So really you're doing 18 times 32, 2 to the 5th, of course. That's going to give you 576. R to the 1st, S to the 5th. And then, of course, 1, 1. I just did 2 to the 6th in the calculator. Or hopefully maybe we know that one. Yeah. Whew, that was a big one. Little breather. Just take a look at the next one. Only to the 3rd power, yes. So 4 terms. So I got my coefficients off the triangle. This is going to be easy peasy. So of course my first term, A, that's going to start at your expansion exponent. Again, you wouldn't have to write the 3 to the 0. I'm just going to put it on for the pattern. Next coefficient, 3. A moves down in power to squared. 3 is up in power to 1. All right, 2 to go. That's it. This seems too easy. A is down in power to the 1st. 3 is up in power to the 2nd. And our very last term, A would be at the 0. Again, not necessary to write, but I'm going to put it for our pattern. And 3 would be cubed. I think we can evaluate this without a calculator even because we've got 1, 1. I'm not going to bother writing those, just A cubed. We know there's really a 1 in front of our A cubed. 3 times 3, 9. 3 times 9, 27. A to the 1st. 1, 1, and we know 3 cubed. Hey, that wasn't so bad. Whew. All right, you are up, my friends. You're gonna try this one. Again, I'm gonna jot down for you your coefficients here, 1, 5, 10, 10, 5, 1. Again, you can always do them with combinations if you want. I'm gonna give you a couple minutes to try this. As you're doing it different, so you should have alternating signs, remember. Okay, I'm just going to set up the first couple terms just to make sure we're all on the right track here. Of course, our first term of the binomial, 2x, that's going to start at 5. Make sure you take the sign on y, because that's going to do the alternating. Of course, 0 power won't affect us there. 5 would be our next coefficient. 2x moves down in power. Negative y up to the first. I'm going to set up the next one. And then we'll see what you got for an answer. 2x cubed, negative y squared. So I'm going to give you a few more seconds to finish up getting your final answers calculated. So of course my first term, I've got my 2 to the 5th here. 1 times 2 to the 5th, I'm going to ignore the 1. 2 to the 5th, 32. And of course y to the 0 is 1. I'm going to ignore that. Your next term, I'm going to have 5, 2 to the 4th. And if it helps, think of that as negative 1. Negative 1 to the 1st. So here's where you're going to get that alternating sign. 5 times 16 times negative 1 is negative 80. X to the 4th y. Okay, for this guy I did 10, 2 cubed. Negative squared would be positive 1, of course, so you get positive 80 here. All right, here's what you should get for the rest of them, my friends. Negative 40 x squared y cubed, 10 x y fourth, and minus y to the 5th. Hopefully everybody got it. Okay, 2 lines of work. Trust me, that is way faster than if I had to write that out 5 times and FOIL it out, okay? Be careful of your signs. Obviously, you have a worksheet for homework. Have a great rest of your day.